4.6 day 2, we are still going to be working with inverse trig functions. So today our goal is to evaluate a double trigonometric function. And example 1 is what a double trigonometric function is. It's when you have a trig function inside of a trig function. And we are going to be evaluating sine of the inverse tangent of 3/4 without using a calculator. So step 1 for this, we are going to evaluate the part in parentheses. So for this one, step 1, we are going to figure out what tangent of -1 3/4 equals. And this is the same thing as saying tangent of a value x equals 3/4. And what we're looking for is x. So when we do that, when we evaluate this, we might not actually figure out what x equals, but we are going to draw it on a triangle. So maybe instead of evaluate part in parentheses, we are going to draw a picture for the part in parentheses. Okay. So we know tangent of a value equals 3/4. And because of the restrictions on our inverse tangent, which is -π/2 to π/2, and tangent is a positive value, we know it's going to be in the first quadrant. And tangent is opposite over adjacent. So once we have that picture, we are going to, so we have step 2, find the missing side of the triangle. So for this one, we're looking for our c value on our right triangle. So we can have 3 squared plus 4 squared equals c squared. That would give us 9 plus 16. That would be 25. And that gives us our missing side of 5. Then our final step, 3, we are going to evaluate the outside trig function. So our entire problem, the first equation, was sine of the inverse tangent 3/4. And we were figuring out what that equals. So when we did that, we first drew a triangle to represent the inverse tangent of 3/4. Now, with that same triangle, we are going to evaluate what the sine would be. And sine would be opposite over a hypotenuse. So our answer for this problem would be 3/5. So this entire problem, we never figured out what the angle was equal to, but by following these 3 steps, we're able to figure out what the equation equals. So now our next example, we are going to write the expression sine of the inverse cosine x as an equivalent expression in x only. And we're going to assume x is positive. So that is a lot of words. We are still going to be breaking down this problem the same as we did before. So step 1, we are going to draw a picture for the part in parentheses. All right, so this one we have the inverse cosine of x. And we're going to assume x is positive. And remember that cosine is limited, inverse cosine is limited from 0 to pi. And we are going to assume this is in the first quadrant. And cosine is adjacent over hypotenuse. So x is the same thing as x over 1, which would mean we would have x as one of our legs and 1 as our hypotenuse. Then we're going to move on to step 2, which is the same step 2 from our last one. We had to find the missing side of the triangle. So again, we are going to use Pythagorean theorem. And 1 is going to be our c value. So we're going to have x squared plus, I'm just going to make that a y for now, y squared equals 1 squared. And we need to figure out what y equals in terms of x. So our goal is to isolate y. Our first step is going to be subtracting that x squared. That will give us y squared equals 1 minus x squared. And I'm just going to get rid of the squared on the 1 because we know 1 squared equals 1. And then our last step to figure out what y is equal to in terms of x is taking the square root. So that tells us what this missing side length is in terms of x. The square root of 1 minus x squared. So now that we're done with finding the side of our triangle, we're going to move on to step 3. And this one, we are going to evaluate the outside trig function. So our original equation was sine of the inverse cosine of x. We drew a triangle for the inverse cosine of x. Now we can find what sine is, which is opposite over hypotenuse. So that's going to be equal to the square root of 1 minus x squared all over 1, which we don't need that over 1, so our final simplified answer would be the square root of 1 minus x squared. So this is how we would express this equation or expression in terms of x only. If you have any questions, let me know. The homework assignment is listed below, and the answer key should be posted on Schoology if you need to check